Okay, here I will do another example of QR factorization using given rotations. So let's say I have the following matrix. Okay. And so first I will try to eliminate this element here. Okay. So my first given rotation will be of the form. There will be a negative sign here, the two cosines in the diagonal, and the sign here. And here there will be zeros, a 1 here, a 0, 0 here. Okay? And so recall, the cosine will be given by the top element of the vector. So here 1. So it will be 1 over the square root of that element squared plus the element we want to eliminate squared, so 2 squared. So we will get 1 over square root of 5. Okay? And our sign will be given by the element we want to eliminate over the square root of that element squared plus the top element, so 1 squared. So we will get 2 over square root of 5. Okay? So if you multiply A with J1, we get the following. Okay, so we get 5 over square root of 5, which is just square root of 5. Okay, 0 as expected, and 3. Then we get 3 plus 4, 7 over, square root of 5. Negative 6 plus 2, negative 4 over square root of 5. And 1. And then we get 1 plus 6, so 7 over square root of 5. Yeah. Then we get 1 over square root of 5 and 2. Okay. Okay. Now we want to so first let's call that A1. Okay. Now we want to eliminate this element here. Okay. So our given rotation J2 will be of the form negative sign cosine, cosine, and sine. Okay, because the cosine needs to be on the diagonal, and there will be zeros here. Okay, and our cosine will be given by the top element, so square root of 5 over the square root of that element squared and plus the element you want to eliminate squared, so 9. So we get square root of 5 over square root of 14. Okay. and the sign will be given by the element we want to eliminate. So 3 over square root of 3 squared plus square root of 5 squared, so 14. Okay? And so if you apply that to A1, we get the following. Okay, hope I will have enough space. Times okay. Sorry. Okay. Sorry, it is really bad written. And so if you multiply that, we get 8 over square root of 14. I think, yeah. No. 9 plus, yeah, 9, 14 over square root of 14. We get 14 over square root of 14, or just square root of 14. Okay. Then we get 0. And then we get 0. Okay, so we get negative 3 times square root of 14 over negative 3 times square root of 5 over square root of 14 plus 3 times square root of 5 over square root of 14. Okay, so we just get 0. Then we get so we get here we get 10 over square root of 14. Okay. Negative 4 over square root of 5. And negative 21. This is a 1. Times square root of 5 times square root of 14 plus square root of 5 over square root of 14 and 13 over square root of 14, 1 over square root of 5, that's maybe 1 over square root of 5, and negative 21 square root of 5 square root of 14 plus 2 times square root of 5 over square root of 14. Okay, and so we can rewrite that a little bit. 0, 0, 10 over square root of 14 And here we can multiply by square root of 5 over square root of 5 on the right, and so we get negative 16 over square root of 5 times square root of 14. Okay? And so here we would get and then here we can multiply by square root of 5 over square root of 5 on the right also, and so we get negative 11 over square root of 5 times square root of 14. Okay? So this is not J2, this is A2. Okay, now if I want to eliminate this element here, so first I will consider this submatrix here. Okay, remember. And our given rotation J3 will be of the form, so let's call that maybe J3 prime, because we only consider the submatrix. It will be of the form negative sine, cosine, sine, cosine, and then J3, which is the matrix that we will multiply with A2. It will be a 1 on the in the first row, first column place, zeros here, and here we'll put J3 prime. Okay, so because we need the same number of columns with J3 as A2 has rows. Okay, J3 has to have the same number of columns as A2 has rows. Okay, and so J3 prime, for J3 prime, let's calculate the cosine and the sine. So the cosine will be the top element of the element in the of the vector in the submatrix, so this element here. So it will be negative 4 over square root of 5 over the square root of that element square, so 16 over 5 plus the element we want to eliminate squared. So it will be, I think we should get 256 over 5 times 14, which is 70, I think. And so we should get negative 4 over square root of 5 times square root of, we can multiply by 14 on the left. Okay, so we get 16 times 14, which is 222 plus 256 over 70. Okay, or just 478. 478. Okay, and our sine will be negative 16 over square root of 5 times square root of 14 over the square root of the square root of 478 over 70. Okay? And so it will be negative 16 over square root of 5 square root of 14. I think you can distribute the square root in the fraction and take the square root of 70 on the top. Okay, so just to make it a bit make it look a bit better, and by the cosine we can do the same thing. We get the following. Okay, so it's just a bit cleaner, and so J3 prime will be it really becomes a bit messy. Okay. Okay, and there shouldn't be a negative sign here. Okay. And here negative 4 over square root of 70. Okay, and so J3 would be the same thing, except that you add a row with a 1 and 4 zeros. So I won't write it here again because it takes a bit of time. Okay. But now if you multiply it with A2, you should get, let's maybe take the entire place. That's not what I wanted. Okay, so I just rewrote it. And so if you do the multiplication, you should get square root of 14, 0, 0. So let's maybe do some more place because we will need it. Then we will get 10 over square root of 14 and 13 over square root of 14, and then we will get 16 times square root of 70 plus 256 times square root of 70. Okay, so I calculated it, and that is what you should get. So as you see, it becomes messy, really messy, and quickly. So that would be your upper triangle matrix. As you see, there are zeros below the diagonal. Okay. So all the given rotations that we applied to A gave us this upper triangular matrix. And so now if you want, you can find Q, because recall A equals QR. Sorry. So Q transpose A is equal to R, recall that. And so Q would be equal to J3, J2, J1 transpose. So you would get J1 transpose, J2 transpose, J3 transpose. Okay? So you know J3, J2 and J1. Okay? And so you could do the computation. But you would need some time. So I won't do it here. But it's so it's how you proceed. Okay? So you have your formula with the given rotation. Once you are finished with the first column vector of A, you only consider the submatrix. Okay? And yeah, that's how you proceed. Thanks for watching.